So we have a video of particles, and we're going to see how we can analyze this video and get the track of the particles to analyze how they're moving. Well, we're going to do this by using MATLAB. MATLAB has a built-in function called video reader, and we can read our MST1 AVI. Well, you see here, this is the properties of our video. Let's open up a new script and do this again. Video reader MST1 AVI. Let that be V. And now we can use get frame. No, actually it's read frame V. Every time we read the frame, we're going to get a new frame of the V. Actually, I want this to be double because it gives you a different type. Now that we have the frame data, we can set a threshold. Let's say it is 150. Also, I would like the frame to be, I want all of the dimensions and just one color dimension, because read frame is going to give you the pixels and 3 different colors regarding these pixels, but we have monochromatic video, so that we can just use one of them, and this color is going to range from 0 to 255, 0 being black, 255 is the white. Let's say the frames, the pixels that are below that threshold is 0, and pixels that are above that threshold is 255. Actually, to make it above, we say not. So now we will have a binary image. Let's look at our image show frame, but actually we need to use matrix to gray frame, and let's see what happens. Okay, it took a little bit of time, but here you can see there are some pixels that we don't want. So we're going to increase the threshold. By the way, let's do like this. We're going to increase the threshold to 170. Now this is looking better. Let's do it like this. Clear all, close all. I just want to check again. Okay, this is looking better. Now what we're going to do is, well, we have found all the pixels that are white. Now I'm going to find their coordinates. Just do find frame equals 255. And now we're going to write a function that is called find particle, and we're going to give this function a pixel. This is a pixel, just x and y, and we're going to give the frame data, and it's going to give us the particle. So simple. Of course, we need to explain how this is working. Let me comment this. Have the image. Now here, how our algorithm goes. We're going to give this particle a pixel, and we want to find all the other pixels that are connected to the initial pixel. Now let's create this function. Function A, B, and let's call it data, or frames, fine. Now what I want is, as I give this function a pixel, I want to add this pixel to the particle. To be able to add it, we need to have an initial particle input. In the initial, we have no idea which particle is containing what frames. At least we know it's containing the initial ones. So now what we can do is particle equals particle plus the A and B. Just not to get confused, let's say current row and current position of the pixel, current row, current position. So now what we do is we just give this pixel into the function, or any pixel you like, it's just, and we take it out as a particle. But this is just not enough. You need to take all of these particles. What we do is we call the function again in our function. We're going to look top, bottom, right, and left of this particle. So we're going to look at right by doing this. We're going to look at left by doing this. And we're going to look at top of the particle and bottom of the particle by doing this. Well, the problem here is that we call our function in here, then we come here, call our function again. And of course, in this function, we call it again. So what happens is we give this pixel, it checked here, added into our particle list, it checked here, added into our particle list, it checked here, added into our particle list. Well, what it's doing is that it is just going infinitely long time, and it's adding every single pixel. So we need to stop it. What we can do here is that we can, if the frame current position and current row, current column is not white, we can return the function so that it will not going to continue infinitely. Yet this is not enough. So what is happening here is that if this goes up and sees that this is black, which is here, the function is going to stop. But we have functions that are going right and bottom. These functions will not stop. It's just going to track everything in here. So to be able to stop it, we're going to make the current frame black, and this is going to solve our problems if we give out the current frame, if we give out the modified frame to the new functions. If everything is done right, we should be able to get a particle, just one particle, with all of these pixels. So let's run this. Okay, I don't want this part. I just don't want to plot anything for now. So let's disregard imshow, anything useless. Let's see if it's working. Okay, this should be, of course, current column. Let's run again. Okay, also, we don't want to echo the answer. And of course, we forgot to get an output in here. The particle and the frame. Let's try again. Okay, now the problem is when our particle gets out of the frame, let's plot it in here, show frame. We should stop it from going out of the frame. So we need a new condition. If currow equals to 0 or currow current row equals to size of the frame 1 or current column equals to 0 or current column equals to size of the frame 2. Return end. And we try it again. I didn't want the image. Let's see what our particle is. So it gives me a set of particles. This is x and this is y. I want to get them not in just one vector. I want to get them in a matrix 2 by half of the length of that particle. So let's do this. Particle equals reshape particle 2 by length of particle over 2. Now if we run this, now we have a nicer looking matrix, and now I want to get the center of mass. Let's say center of mass equal to sum of particle. We don't want to, just to show that we don't want to sum one, we need to sum this way and over, of course, size of particle 2. Size of particle 1 just gives you 2 because it's a 2 by 51 matrix. And let's see if this has worked. Oops. What is CM? So we just got one particle's position. Now what we're going to do is we're going to put this in a loop. Move here. After this one, we're going to say that if is empty A, if A is empty, then break out of the loop. Well, how does the A get empty? When we run this function, the frame is also altered and the particles positions are black right now, because here you see we made the certain pixels black. Now when we try to find the white frames, white pixels, in the end, when all the particles are found, we're going to get out of the loop. And I would like to get a I equals I plus 1, I equals 0, and center of mass, rho and I equals this. So let's run this. Too many output arguments. What do you mean? Oh yeah, that has nothing to do with it. Okay, so let's look at center of mass now. So now we have set of particles. What we can do now is that let's stop this plotting and image show read frame V, hold on, and scatter CM 2 to all, CM 1 to all, because first is row, it should be 2 for the extraction. Let's run it. Okay, it's hard to see this way. Fill. Well, you can see here we are able to track our particles. I don't like this one much, but it's fine, I guess. Now we have the trace of our particles just for one frame. What we are going to do is put it in a loop for higher amount of frames. What I would like to do is, let's break this CM down into CMX, and let's open up a loop for I equals, not I, frame loop equals 1, 2. We don't need to read video all the time, of course. We just need to read frame loop 1, 2, video. What was it called? We're going to have to do it like this. We just need to loop through all frames. So if we go like v dot frame rate times v dot duration, we get the total number of frames. So we have like 10,000 frames. So let's loop through all the frames. In the reality, I don't think we need all the frames, but well, just for the tutorial, you may need to loop through more frames. I will just jump them through by 100. And let's end this. This is our loop. I would like CMX frame loop row and CM1 and all. And for CMY, again, frame loop CM to it all. Okay, this may take some time. Let's just take very few amount of frames to see if it's working. Of course. This is just a stupid mistake. We're just going to wait a little. Let's see how CMX is looking like. It's looking very interesting. Probably not very good. Okay, let's try to scatter. Let's try to scatter CMX. CMY. Close all first, then scatter. Okay, so we got something. We can check their movement like this. Now that this is ended, let's say for I equals 1 to length of CMX, we can scatter CMX, CMY, let's say clear figure, draw now, end. Well, so I've gathered some data and made some changes in the code. Now this goes from size, it was a little bug, this was length before, and also instead of saving at the frame loop, I just save at the C so that there wouldn't be gaps. And now we have the data. Let's run this. You can see the Brownian motion of the particles. Well, what we're going to do is, this is the end of this video. In the next videos, we're going to see how we can calculate the MSD, how we can, if there's a trap, how we can find the stiffness of that trap by using this data.